So last lecture we started talking about sequences, specifically strings, and I kind of left it there. I'm now going to pivot to our last point, which is functions, because that's what you need to do the latest assignment, right? So we're going to go over how to write our own assignments, and like everything else, I'm going to incorporate it into this, right? The first exam, I'm going to write a practice exam tonight and or tomorrow. You'll have a practice exam by Thursday, and then I'll let you know, based on what's on it, whether the exam will be next Thursday or the following Tuesday. Then we'll have another exam after that, within a number of weeks. But this exam should cover like basic if statements, basic expressions, basic for loop stuff, basic turtle stuff, and then basic, very, very basic functions, basically taking in one parameter. It's not going to be you'll see it on the practice exam, and again, the practice exam is something you definitely want to just take a look at. I'll go over the practice exam before we actually do the exam, like the day before we have our exam. So you'll have not necessarily an answer key, but a review session for it. All right. So as we learned with doing repetition, programmers are lazy. Okay, we are lazy by nature. So let's go ahead and classroom. That didn't work. Classroom. ITP. Spring 2020. Okay, let's call this fun functions.py. All right. Now, we've been using functions for a while. For instance, over here on the interpreter, I'm just going to use a couple. We've been using the int function to take any string and convert it into an integer. That's a function that's built in. We can let's see. We have the str function, which takes anything we have and converts it into a string. So, like if we take 3.4, it's going to convert it into the string 3.4. Right? It takes anything we have, converts it to a string. Okay. We've also seen that basically that some functions are not built in, and we have to use them like this. So import math, and this has like stuff like the trigonomic functions. And so this is saying from the math file, there's a function in it called sin. Well, sine actually. And sine of 3 is that amount, math.sine of 3 times math.pi. Math.pi, is there? Yeah, there we go. Math.sine 3 times math.pi, which is also a did it again. It's just, sorry, it's instinctive for me because that's the way it would work in Python. Sorry, not Python, Java. Because yay, having to do multiple languages at once. So that works out. So we can use functions from libraries. We can also use functions in variables. Also sometimes have their own functions associated with them. Like for instance, if we use turtle, import turtle, magic word to create a turtle, Bob is equal to turtle. Most of the turtle questions are going to be fairly the turtle questions on the exam are going to be very, very straightforward. They're going to be along the lines of write a program that makes the turtle draw a triangle was last semester's exam question. And then here's an image that's very similar to what was on the practice exam. Fill in the blanks that will make it the turtle, so that the turtle will program that's above it will create this image. So there we've created, and then Bob has a bunch of functions built into him. Bob.forward 50, and this is what we call, these are functions that are attached to objects. We don't really learn about them in this class, but some variables like strings, some piece of data like strings and turtles, they have functions built into them, and those are called methods in other programming languages. But essentially, some objects, some variables are very, very powerful. They're not like ints that just hold the number. They also have data plus they have actions they can do. Right now, we're going to just learn about how to write our own functions. And there's a reason we call it a function. It's because it's very much like a math function. So here is the classic function. So this declares a new command in Python called. So the way you define a new function is with def. You can think of it as define function, and then the name of the new command you're going to call it. I'm going to call it spam because we're working in Python and spam and eggs are a thing, right? If you don't know, just look up the Monty Python skit about spam and eggs, you know. And what this will do is that we define this as eggs. As we've defined the function spam as just a simple function that will print out eggs. Print calling the spam function. Spam. Print. Done. You don't really need to copy too much down right now. Done calling the spam function. It just occurs to me that I might be cutting off some valuable real estate space. Oops, in my recording, and that probably did all sorts of nastiness over there. Let's just move me over here for right now. There we go. And also, since I'm not as important, I'll just make myself smaller. There we go. Sorry, I'm trying to adjust it so that the recording, that again will be nasty. I'm just trying to adjust it so that the recording is not going to be as, there we go. So we've got calling the spam function, spam, done calling the spam function. So I'm going to do it, so I'm going to run this. Calling the spam function, eggs, done calling the spam function. Okay? So a lot went on there. Notice that, but one rule you have to remember about functions that you're going to probably mess up sometimes is that you'll forget to leave the parentheses off. It's not going to run an error or anything. It's just not going to do anything. Spam is kind of now a variable, actually. And if we print it out, this variable contains the function. Done. See, it says this the function spam at this memory location. 0xFF02A180DD. That's a hexadecimal address, right? We kind of went into binary, but not too much. But just we know that basically that these are 16-digit numbers that have 0 through F. So 0 through 9, then A, B, C, D, E, F. So to call a function, you must invoke it, which is a cool word because it makes it sound like we're doing magic, right? You got to complete the invocation. So to invoke it, we just simply use parentheses. So only if magic was that simple. If you fail to invoke it, it's just not going to do anything. So to invoke it, you use the parentheses. If we change this function to do something else, spam, eggs, and spam, right? Then it will now print out something, spam, eggs, and spam, print spam, spam, eggs, baked beans, spam. Again, all from a skit, probably. So now it will print out those two lines. Calling the spam function, spam, egg, spam, 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 eggs, baked beans, spam. So the point here is also just like the loops and the if statements, what goes on inside on inside a function, print print outside. Sorry, let me just put this out outside the function. What's inside the function is what's indented into the function. So this outside the function, right, it goes through it, and this is how the compiler works. It sees, or not the compiler, this is how the interpreter works. It sees a def, so it knows to expect a function declaration. So it goes and looks at that indentation and says, aha, everything that's indented, that's inside the spam function. And once I don't run this code, this is just what I'm making note of. And then once we get over here, it says outside, it got over here, we're no longer indented, so it prints out outside the function. Then print, then we call the spam function, and then we print done calling the spam function. Okay? So we can call it multiple times. It's not one use only. Spam, right? And in fact, now I can actually call from here now because I've defined it after I've run it, right? I actually have to run it. Once this is run, I can actually call it over here, which is pretty cool. I can do it in a for loop too. For I in range 5. Print, or we're not going to print spam, we're just going to call spam. Okay. It'll do it 5 times. By the way, printing the function like this isn't necessarily going to do anything a lot of the time because notice that it's printing out none, 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 none. This gets into return values, which I'll get in, which is not something I'm going to deal with quite yet. We're going to slowly transition from printing being the way that methods work, or from the way that functions deal with data, to returning being the way that functions deal with data. And the reason for this is that right now, we're okay with stuff printing stuff in functions, but once we're done, we're not going to print stuff out. Okay, I'll explain return to you today, but the homework doesn't assume that you're going to be doing any returning. You're just going to be doing printing. Sorry. All right, so, but anyway, the reason they're called functions is that, you know, you can get stuff like this. Let's define an f of x. Oh, notice that we put a colon just like we would for an if statement in a for loop. F of x. So now notice I put a variable in there. X doesn't exist anywhere else in the program. That's perfectly fine. I'm going to comment all this stuff out as well. That's fine because guess what? The spam function still is going to exist. It's perfectly fine. So it's fine for me to comment it out because I can just call it again and play with it again when I'm ready for it. There's also a big reason we like to use functions is that if you write your code in discrete parts that use these functions, you can easily copy paste your functions from one program to another, or you can import your own homework. It's nice. So function f of x, let's just say, let's print twice the value, 2 times x. Okay. And the way this works is that I can't do this anymore. Okay? It says, hey, there's an error. You're missing a positional argument, x. A positional argument? Are we like having a fight about like where things are supposed to go? Well, kind of. It wants a variable inside these parentheses, right? I mean, to use the example of math back down here, import math, right? Math.sign, if I just simply say, if I don't provide anything for math.sign, it's going to give me an error saying math.sign takes exactly 1 argument and you gave me 0. 0. Now the reason it's arguing with me is like it doesn't make sense to call the sign function on nothing, right? Could you imagine like calling the sign function on nothing and what the output would be on sign? It shouldn't be 0. It should be like it should be an error, right? So what it's saying is that what we're saying over here is in this def statement is say provide me an x. If you provide me an x, I'll do something with it. Now, other languages, we put in restrictions, like provide me an integer called x. Python, we just hope that the user is going to pass the right kind of data in. For here, we're hoping they're going to pass some kind of number to us. So let's pass it a number, f of 5. So that will take, so here's what's going to happen. This is going to copy the 5 over, and we're going to do 2 times 5. Make sense? 25. It's going to give me 50. Okay? Let's go do something a bit less abstract. Right? Let's go ahead and play around with let's go ahead and incorporate this with a turtle now. Okay? Import turtle. Let's go ahead and just set up all the turtle stuff over here. Bob is equal to our turtle. Turtle.turtle. Shape. By the way, you can put these functions anywhere. I'm going to go ahead and do this, right? You can put these functions anywhere you want in your program, but by default, put them up above before you kind of do much of your code. And the reason is that this, you'll see, gives me an error. F is not defined. And here I'm trying to call F before we use our function, which makes sense, right? We're going through line by line. It's wondering, what the heck is F? Well, it's a function, but we didn't get to define it yet. So, right, no, it's not, I swear. So what we want to do is we want to define our functions before we call them. Okay, so let's go ahead and say Bob dot shape size is equal to 2. Bob dot, and that should Bob dot pen size is equal to 2. And that will give us that. I'm just going to keep him an arrow today. Okay. Let's go ahead and write a new function. One that will be a bit more useful. Let's go ahead and draw, and we're going to constantly improve this function, okay? Def draw square. Okay, this is a function, by the way, that if you're taking notes by paper, you'll just want to kind of pencil stuff in so you can erase it, because there's going to be a lot of stuff that goes on. Bob, and what we'll do is that we'll simply have Bob draw a square. Our first pass through this, we're going to do something like this. For I in range 4, Bob dot forward, we're going to have him move forward 50. And this is kind of going to be to demonstrate the power that writing functions and writing them generically have. Bob dot forward 50, Bob dot right turn 90. Okay. So we're going to just call draw square over here. Okay. Oh, forgot my colon. Although, right, and it draws a square, right? We see draw square, so the program knows immediately to jump over to here, where it sees this for loop, which it says repeat the following 4 times. I don't have to bother keeping track of I because I'm not going to use it. Right? Right now we're not using a lot of. We're going to be using some loops that will keep track of I in this assignment. That's going to be the biggest headache that you're going to have this assignment, but that's okay. Bob dot forward 50, Bob dot right turn 90. All right. So now suppose that I'm working on this. I'm working on another program. Just give me a second. And I have this draw square function. It worked great for me over here. Okay. And so I go to write my. So I'm writing a new turtle function, but it's with Alice instead of Bob. I'm not even going to bother running this. What's the issue? Yes?
It says Bob.
Yeah, it says Bob. There is no Bob in this program. It's Alice in this one. So I'd have to go through and change this to Bob, which is annoying, especially since I'd have to change it possibly for any other program I turn this into. So what we can do with variables is we can make this a bit easier to use. Instead of like assuming it's always going to be Bob, we can let the user provide which turtle they want to draw with. Okay? So I'm going to call this turtle maybe Pet, or maybe I'll call him T for turtle. Personally, I prefer, but let's call him T. Instead, we'll change this to T. Now draw square won't work as I'm calling it, but now if I say draw square Bob, now it will work. And we'll say, hey, Bob, we're going to take Bob. He's going to be T in this case. Does that make sense to people? So here we're saying draw square Bob. And notice that here's the important thing. Bob and T here are the same guy. Right? I might copy a number over, but what we do is we copy what's in the variable. If it's and this is a bit of a subtlety here that gets into the way programming languages work. Okay, if it's a number over here, we're going to copy the number directly over. If it's something more advanced than a number, though, we're going to copy over the memory location of what we're using. In other words, we're going to copy over where we find Bob so that this can use it and we're not going to accidentally end up with two Bobs. Make sense? Essentially, what we're going to say is that T is just going to be another way to refer to Bob. It's going to be Bob's nickname here. And if we were passing in Alice, it would be Alice's nickname here. So now, if we were to take this over here, oh, and I already closed that one. If I were to take this and use it with Alice, I could pass Alice in instead, and that would be perfectly fine. In fact, let's go ahead and do that now. Alice is equal to a different turtle. Dot turtle. Right? Alice dot color. We're going to make her red just to make sure that we can see that she's different than Bob. Alice dot forward. Alice dot, let's use the go to. Alice dot go to 200, 200. And then draw square Alice in this case. Right? Now Alice went over and she drew her square. Right? So it was Bob's turn and then it was Alice's turn. Okay, and basically this was just a command that both of them could use. We can also use this to like adjust the size of this. So I can add in more than one variable into a function, which is pretty nice. For the programs you're going to be writing, you'll probably just need one, but we can add in multiple ones, like this one, size. So over here, I can, right? And here, I can say that this, now, as I'm doing this, I might forget, like in a couple weeks, what each of these are. So I'm going to leave a comment for myself. So I'm going to remind myself of what this does. Draw a square. Square. T is the turtle doing the drawing. Size is the size of a side of the square. Right? And now there's no confusion if I'm talking about perimeter or something, right? Or area. Right? That would be a bit harder to calculate, but I'm going to be lazy. I'm going to say size is just going to be the size of a side, right? And to do it, and each side of the square, it's basically the amount the turtle moves. So instead of drawing 50, I'm going to put this over here. Now, again, if I run this, it's now going to crash because it says, hey, you're missing size. You don't have a size right now. So let's provide it a size. You might see functions, though, that do this, though. Well, actually, I'll show that in a minute, but let's just provide a size, 200 and 300. So Bob's going to draw a size 200 circle. Alice is going to draw a size 300 circle. Square, circle. Yeah, it evens out anyway. Okay. Square. Okay. So we've got ourselves what we've drawn. Okay. Now you might say, wait a second, like, I have to provide a t, I have to provide a size, but what about stuff like print? Print's a function, and sometimes you've used it where you use one value, like print out 3, and then you say print out apple, and it works perfectly fine, right? You can use as many as you want. That gets into advanced things you can do with functions, but one thing you can do is provide a default argument saying, hey, if the user doesn't provide this, by default, we're going to say that size is equal to 100. So that's what that equal sign says. That way, if they just give me a turtle, but not the size, then that's easy. So Bob. So now I'll just take out what Bob's saying, and so now we'll see draw square Bob, draw square Alice 300. So he drew a 100 size square, and now a size 300 square was what Alice drew. Okay. So we can do a lot of cool stuff like that. Let's see. So let's go ahead and show you one of the things I did on the last exam using a function, okay, which is stamp pyramid, which we're going to learn a lot of different new things with turtles, but that's okay. I'm going to bring in our turtle again. This is a question I gave on, or something very similar to this on the exam. And I turned it into a fill-in-the-blank question. Okay, right now I'm just going to pass in a turtle rather than anything else. So first thing I do is I tell the turtle that we're using t.pen up. And what that does is that tells the turtle to move their pen up. So let's see what happens when I move forward when the pen's up. So again, I'm just going to comment this stuff out because if you want to refer to it later, you can by uncommenting it out. Stamp pyramid. T. Okay. Bob. Right, if I pass in T, there is no T defined for turtle, so I'm not going to. Instead, we want to pass in the turtle we want to use. Bob. Turtle has no attribute forward. T. Help if I knew how to spell. Okay, and there he goes. Notice that Bob moved forward 500 spaces, but because his pen was up, he didn't draw anything. And now if I told him to put his pen down, right? We can put our pen down. And then tell him to move forward. Let's do 300 and 300 this time. So pen up, pen down. Okay, so where am I going with this? Well, we have something else called the stamp function. So let's go ahead and just show you, and it works great when you use a for loop like this. For I in range five t dot forward. Actually, I only want to. I'm not going to show you exactly what's on the exam. I will do that later because I want to avoid nested for loops right now. If I can. So we're going to move forward 100 steps, and we're going to do t dot stamp. So let's see what stamp does. That's what stamp does. So now let's add a bit of imagination to our turtle. Besides dragging a pen along on his tail, imagine that the turtle's little belly is covered with ink. And then when you tell him to do stamp, he does a little belly flop wherever he's sitting. Okay? So he makes a stamp of himself. And that's exactly what happened here. So he 5 times, move forward, stamp, move forward, stamp, move forward, stamp, move forward, stamp, move forward. Well, we can't really see that he moved forward here, so I'm going to go ahead and tell him to I'm going to tell him Bob dot go to x coordinate 0, y coordinate 50. There we go. So there's Bob, and now we can see he's made 5 stamps. So what we can do, though, is that we can say, let's see. Let's change this to, because I'm not doing a pyramid, I'm going to do stamp row. P and num stamps. So what we can do over here with this for loop is that we can modify the number of times this for loop occurs. Okay? So I'll change the function over here. Okay. And this is going to get maybe a bit advanced, but that's okay. So right now it's not going to do anything, right? I got to actually pass in an argument. So what I'm going to do is I'm going to pass in the argument 5. So now it's not going to work any different than what we've been doing over here. So notice instead of doing 5, the for loop doing it 5 times, it's going to do it num stamps time, where num stamp is the number of times I say it. So if I say it 5, we're going to get 5 stamps. If I say 50 stamps, we're going to get 50 stamps. Num stamp, it's plural. And it's still going, I'm sure. Just went off the edge of the screen. Bob's very enthusiastic about his stamps. So we can do something like that. We can say, hey, do this, boop, 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 which is pretty cool. Okay. So we can pass in a parameter and use it in a for loop. Make sense? Okay. Def stamp square t num rows. So one of the ways that we can avoid messing with nested for loops is to just have functions call functions. So you can have a function call function. For I in range num rows. So this function will run however many times we tell it to, which is num rows, right? Run num rows number of times. And what will we do with it? Let's say we'll say t dot go to. So this is going to be incorrect at first. I'll fix the go to later. T dot go to 0 0. T dot. Okay. Go to later. T dot no. And then all we need to do is say stamp row. Num rows. So let's see what this one does. Oh, right, I didn't call it yet. So stamp square. Yeah, I'm so on top of my game today. Num stamps. So num stamps needs an argument. Right, stamp row t. So it's not really doing too much, but what? So ignore the name stamp square right now. But what is it doing? It's saying we pass in 5. So 5 times. What we want it to do is do this. We want it to repeat this 5 times. What are we repeating? Go to 0, 0, which is where Alice is right now, and then we tell it to stamp a row, which is, and we're going to stamp the row using the turtle that we've already defined, and we're going to stamp a row, and the number of stamps that are going to be in the row is going to be equal to the number of total rows we have, which was 5, right? So 5, same variable here, 5, 5. Right, because when we're doing a square, we want it to have the same number of rows and then the same number of stamps per row so that it's a square. So, and then we had it run stamp row, which you know what that does already, right? Making sense so far? So that's pretty cool. You can have functions call functions. It's really nice. Okay. Now let's adjust this. What I'm going to use is I'm going to use the I. I'm going to use I. So I'm going to say the Y position is going to be equal to 0 times -1, which is weird. No, not 0 times -1. We're going to use I times -100. There we go. So remember, what is I? It's going to be 0 first, then it's going to be 1, then it's going to be 2, then it's going to be 3. So now let's see how this affects our program. It's going to be really cool. So what did it do? Well, what it did was that it moved forward, is that we had this move forward. Move this over here so that you can see it all together. So what we saw over here is that we have stamp square, and what it does is that we told Bob to stamp a number of squares, stamp a square with 5 rows. Okay? Now how do you do that? Well, for the number of rows, what I'm going to do is I'm going to go to 0. I'm going to go to location 0 and then I times -100. Now remember, the variables for I are going to be I. Yes?
So
why doesn't it stamp where Alice is standing? Because we tell it to, excellent question, because we tell it to move before it's stamping. Right? So this is 0, 0. So we're going to tell it to move forward 100 steps, then tell it to stamp. Right? If we told it to, and I'll get back to what I was talking about in just a second, but because if you're the person asking the question, then I guarantee at least 20 other people are thinking it, right? If I were to do the stamp first, before we moved, it's going to stamp over where Alice is. Right? Make sense? But because we moved before we stamped, it's just kind of shifted forward to the right. It's shifted to the right a bit, like that. It's not that there's force there. It's just that the screen is kind of, there's only so much screen space I have. All right. So what we did is that basically we say I is equal to 0. So we go to 0, 0, and then we stamp a row starting at 0, 0. Then we go to 0, 1. Or sorry, then we go to 0 and I is equal to 1. 1 times -100. So we go to 0, -100 and stamp a row starting there. Then we go to 0, -200 and stamp a row starting there. 3 and then start there. And then 4 and start there. Now, it's also completely possible that we do it like this, by the way, that we did it like this instead. Let's see. Ooh, that's interesting. Control Z, Control Z, Control Z, Control Z, Control C. Let's Control C this. Then I just put this over here, and then made it look like this. But I'll be frank with you. That's scary looking, right? You've got this for loop and a for loop, which is nasty. Oh, and then we'd have to say, sorry, I'd have to take this out, and then it would have to be num rows minus I, which is, yes?
Can you call other functions no matter what order the functions are in?
Yes, you can call, right, because this is saying call function, because we aren't actually calling it, we only get into trouble when it's actually run, right? So, now, so you can call, so it doesn't matter which order we put these in, right? Until they're actually run, we're not actually going to run into any issues. That being said, it is possible to kind of shoot yourself in the foot with this kind of stuff. Def A calls B. Def B calls A. Call A over here. You kind of see that this is a bad idea. Run it. See, error, maximum recursion def exceeded. Basically, it's saying we called too many functions. You can only call so in theory, there's no limit to how many functions you can have call each other, right? You could have you could have function 1 call function 2, which could call function 3, which could call function 4, and so on and so forth. And that could go as high as you want in theory. In practice, there's a limit to your computer, to the memory your computer allocates for that. But you shouldn't worry about running into that limit because it's somewhere in the thousands. If you get this error, something went horribly wrong. You essentially hit an infinite loop of some kind. Okay? So it is possible to run into this kind of situation with functions, but generally not. Let's go over the kind of things that I like to do for your homework, right? Like, so your current homework, I have you like drawing something that, let's go ahead and look at Canvas. I'm not really doing too much with turtles. Maybe I should have, but I want to make sure you can do your homework before I move back to strings is the point. Because, by the way, this is actually, they did just simply put a monkey in front of this computer and just started photographing what he would do. And if you animate it, he just gets so frustrated and like, anyway, it's just simply a very good way I feel when coding happens. All right, assignments. Here, first loop problem set. Loops 1. All right. Loops and functions, right? So here you're going to use something called, here I'm just reminding you how loop works. Function called, that will print out the 99 bottles of beer on the wall program or thing. One that will give you a multiple, oh, I messed up there. Need another row. Multiplication table, doing a summation of squares. But then there's also these, which give my students some trouble because they're supposed to, which is using for loops to draw this figure, and then using a for loop to draw, and functions to draw these guys over here. Okay, which is that if you give me 4, you're going to print out this because it will have 4 lines, 6 lines to do this, and 7 lines to do this. So let's go ahead and now, in other programming languages, you'd be required to use nested for loops. But Python's nice. Python's really nice. We don't need any of that. You've got the replication operator. Makes it easy. So let's go ahead and do a def draw text pyramid before we do our turtle pyramid, right? So text pyramid, what I want to draw is something that looks like this. Whoops. So if I'm given 5, I want it to look something like this. Make sense? I want to print that out. If I'm given 6, I want this, right? Essentially, I'm going to draw an ASCII pyramid. Make sense to everybody? So we don't need turtles to do this. Basically, I just want the size of the pyramid over here, right? How many rows does the pyramid have? So maybe I'll just call it rows instead. That makes sense. Okay? So I have, first thing I know over here is that, oh, let's think about this actually. If it was a square, this would be super easy, right? Think about it in terms of a square first. If it was a square, all I'd have to do was this, right? Yeah, it doesn't precisely look squarey, but there's 6 rows and there's 6 columns, okay? Okay, so what we would want to do is repeat this the following amount of time. For each row in range rows, what do I want to do? I'll print out, I want to print out 1, 2, 3, 4, 5, 6, right? Draw text pyramid. Draw text pyramid. Let's go with 6. There, we've got, so that works for that, right? We print out 1, right? What am I saying? I'm saying do this 6 times, where the this is print out 6 hash marks. Mind you, it's not exactly going to work if I tell it to do a 3 by 3 square, right? Because, right? Okay. So maybe instead of doing this, I can use the replication operation, right? Printing out 6, printing out 1, 2, 3, 4, 5, 6, we can change that to doing that, right? We're still going to be printing out too many, but that gives me now an idea that we can use, which is that we can replace this with the variable. Rows. So for every rows, we're going to print out a number of hash symbols equal to the number of rows. Make sense to everybody? Make sense? How I'm using these variables. And now if I do 7, boom, 7, right? And if I do 25 of them, cool. But that's a square and not a pyramid. So this is a variable. This doesn't change through the program, but I do have access to something that does change through the program, right? And I'm just going to do comma and row. Right? Row changes throughout the program, whereas rows does not, right? Row being the current row. With the for loop, that changes, even though the range won't change. Rows, row. I like programming like that. If that is annoying to you, then we can just simply say for line in range rows, which might be a bit easier for you to digest. So for each line in the square, or in this pyramid, right? 0, 1, 2, 3. So rather than trying to multiply by rows, what if we were to multiply by line? Let's go back to something smaller. Let's go by a 5 by 5 pyramid. So we've got a blank over here. Why? Well, because in line 0, line is 0. So 0 times, just prints out an empty string. Then we have 1, 2, 3. So we've got a pyramid. So how do we fix this so that instead of getting 0, 1, 2, 3, 4, we get 1, 2, 3, 4, 5? Any suggestions? Yes? Yep, we can just add 1 to it, which we'll need to do in parentheses because of the order of operations. Because otherwise, it would think we wanted to concatenate the number 1 to a string. So here, we're saying 1 more over here. 1, 2, 3, 4, 5. Now, there are other things there are other tricks we can do with with for loops, by the way, or not specifically for loops, but specifically with the range function, which you might find handy. You should be able to do everything you need with just using a for loop like this and using the replication operation for those, and some very clever thinking about the math. This is essentially the hump assignment, I guess you might say. This is the assignment that basically you'll want to have a lot to think about. It will make you feel stupid. You're not stupid. You're just exercising muscles that you really, mental muscles that you haven't used before. It's like, if you're out of shape and you start exercising for the first time, right? I'm not saying you're mentally out of shape or anything. I'm just saying that these are muscles you haven't used for the first time, in a while. Okay. So what else can I do with that, I just want to show you what I can do with the range function as well. New file, a look at range.py. Because we learned about multiple arguments today, and range is a function as well. It's technically what we call a generator, which is something I don't teach in this class, and I didn't learn until I was in grad school because it messed with my mind so much about how it worked. It's a special function that you can stop and then resume. And functions aren't supposed to work like that in the mental model, but somebody thought that was useful, so they made it so you could do that. All right, so for I in range, notice that basically when I start this, it comes up with a handy thing saying stop or start, stop, step. So let's go ahead and do range to 50. Let's put in our colon and print out I. That's all we're going to be doing for this program. We're just simply going to print out the numbers and see what we get. Okay, so we got 0 through 90. In fact, because of the way that this is working, give me 1 second, I'm going to switch my programs at this point. Just because of the display issues I'm having. Okay, here we go. So I'm going to be using this desktop classroom ITP string. This is just a program I use that's on Linux. You can download it for Windows as well. It's called Geany. It's a basic text editor that works with any programming language. It's not going to really affect any of the way that stuff runs over here. So other than turtles, I'll just have to do turtle.done for stuff. Look at range. Replace it. We're going to use it. Okay, so for I in range 100. Also, the colors will be different, but that's okay. Print 50, or print I, and the reason I'm doing it like this is because now it's not cut off on the right, and if I run it, it now prints out in the console like this. So it makes it a bit easier for me to deal with because now I can easily close it just by hitting a key. It's my preferred. So continue working in idle. I'm not saying to switch to Geany because of anything. I use Geany because it works for me. There are a lot of different programs you can use to write your own programs. Text editors are serious business, and text editor wars are a thing. I personally vote for use what works for you, and idle is pretty good. Okay, so now let's look at using start and stop. 0, 100. This means we're going to go up, start at 0 and go up to, but not include 100. That's no different than actually what we've already been doing, right? Because when we were doing this, it was saying let's start at 0 and go up to, but not include 100. So what I can do over here is maybe say negative 100 to 100. And now we go from negative 100 to 100. And here's kind of the genius about why we start about why we don't include the last thing, but we include the first thing. How many numbers got printed out there? 200. Now the reason being is that we can actually figure it out pretty easily by taking the stopping point and subtracting the starting point from it. 100 minus negative 100. Now, if we were including that, we'd have to add +1 to everything, which would kind of make the math just a tad more difficult. But it's very easy to kind of look and go 100 minus negative 100, mentally say that's 200. Or better yet, 50 to 100, how many numbers is that? That's 50 numbers, right? That's 50 numbers. 100 to, don't believe me, let's look at a much smaller sample. 5 up to, but not including 10. 5, 6, 7, 8, 9. Right? So that's part of the reason we do it like that. There's a lot of reasons, but that's part of the reason. It makes the math really easy there. So we can start and stop at any range, so long as you're going up, right? Negative 50,000 to actually, better idea, right, because I'm going negative. So going up means 4,000 and then oh, yeah. 50, and then these guys should be 999 and 999. There we go. Oh, it's always annoying working in negatives, because if I didn't do that right, we'd be waiting a long time for that program to complete. All right. But so what's the last? So then there was also step, which is really, really cool. So let's go from 0 to 10 and then step on 2s, which once you see it, it's pretty intuitive what that means. That means rather than incrementing by 1, we're going to increment by 2 in our range. 2, 4, 6, 8. Who do we appreciate? Or something like that. Okay, 5, 0, 5. Goes up to, but doesn't include 10. We're going to count up by 5s. We go up to 100, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. It's going to go up by 5. So this is a great way to just print out certain numbers that you only want, or to go up by certain ranges you only want, right? So that's what you can do with range. Now there's a reason I bring this up, because when we were talking about strings last lecture, I had mentioned something called slicing. Now, we were talking about indices, but I hadn't talked about using the for loop, right, with the string yet. Okay? Right? I hadn't talked about going through using a for loop for the string. So let's go ahead. Okay. Let's go and again, home, classroom, ITP, string slice and for.py. Okay. So let's look at so we saw the in. Everybody remember the in operator, by the way? What we were talking about. So print s in hello, right? Remember that from Thursday? This will give me false. But if I do he in hello, it'll give me true, right? You remember that this is not the only time we've seen in. we've seen it on a for loop, right? So let's look at this. For letter in text. Notice that I didn't use a range over there, and I didn't call it I. Remember, I can call this whatever the heck I want it to be. I'm calling it letter because that makes more sense there. So for letter in text, print letter. For on string. Hello? I have no idea how I've even managed to type this fast. And it's not that fast too. So, hello. Let's take this one letter at a time. Now this is also something that if you're coming from another programming language is really weird about a for loop. You don't need to know how long it is to run it. You just tell it, run the for loop over it, and it'll do it, which is awesome. So for letter in text, print the letter. Let's take a look at this. Right? HELLO. That's all it did. It just printed out for each letter in the text. The text was hello. It printed out HELLO. Printed it out. Make sense so far? Right? So we can use a for loop on that. So it's fairly straightforward. We can also do other things with that. We can say, hey, for letter in text, print letter dot upper, right? Because each letter in itself is a string, right? And so what does upper do? It makes it uppercase. So now we go HELLO, right? Still tell anybody who types in all caps to stop shouting. Let's see. So this is actually fairly straightforward for a loop. There's not really too much you have to figure out there. Where it becomes a bit trickier is that if we actually want to change some stuff up. Def for index in string example. And I'll leave out the example text. And then this will look a bit different, but I in range. Now, if you're coming from C or Java, as opposed to having no experience, right? If you're having no experience, if you're coming with no experience, this looks great. And if you're coming in from C or another programming language, this looks mildly confusing because you're like, how is this working? Unless you knew about a for each loop, because that's what this is in other programming languages. This is the for each loop. By default, all for loops in Python are for each loops, and that is the way it should be. But if you have to use your indices, like say we only wanted to print out every other letter, we kind of need to know where the indices are. The lie that I will expose shortly, or leave it to you to expose, but for I in range, len text. You say if you're coming from C, this looks more familiar. For index in range, let's go ahead and say that. For index in range, so remember that's 0, 1, 2, 3, 4, 5, right? If we're talking about, or 0, 1, 2, 3, 4, if we're talking about indices for hello, right? So we'll print out index letter. Okay. And then I'll just simply take this, copy it over here. Hello world, you can put whatever you want in there. What did I forget? A colon. Colon. Don't forget your colon, it could make a mess. Letters not defined. Haven't put in a letter. That's right. Print out index. So let's just go ahead and do this. So letter, so it does hello, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because this has the following indices. Let's go ahead and look, right? And I'm just going to mash on the keyboard for a second. Right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, index 10, index 11. Right? Makes sense? So just a visual guide there. So it goes through, pass in hello world. Hello world is now the text. For index in range, so this is a number, in range, length of text. What is the length of the text? There's 10, there's 5 letters plus 2 plus 2, what's it called? Plus 2 non-letter characters. So it's 12 characters total. So for index in range 12, so 0 through 12. Now, if we remember our subscript notation, we can do something like this. Letter is equal to text index. Right, this will take, everybody remember the subscript notation we were doing? Vaguely. And now what I can do is I can print out both the index and the letter. Now you might be asking, why would I want to do this? Right, 0, 1, 1E, unless I wanted to know what the indices everything was at. And the answer is that's pretty much all you need to use it for if you care about the indices, which generally you don't for strings. But say we wanted to print out every other letter, we now have a range, we now have a way to do that. We can say start at 0, up to the length of the text, and then go by 2s. And now we'll print out every other letter, which is or something like that. So you're not going to use this too much, but it is useful to go manually through it. Let's see. So I'm going to introduce slices before we head out. Again, I wanted to go over everything that you needed for the homework before I resumed with where we were on Thursday, because I'm terrible at organizing, but it's just the way that things pan out. I mean, there's the issue with programming is that with teaching programming, the initial stages, that there's just so much content that all links together to build things that are fun. So let's go ahead and talk about slices, which I'll do in the terminal. Okay, right over here, I'm just going to run our Python interpreter over here. So text is equal to, this is a happy little string. Okay, you can call it however you want, by the way. It's pretty long, even though it's a happy little string. It's 29 letters long. Now, suppose we just want to get a chunk of text out of it. That's where a slice comes in. And a slice is pretty awesome. And fortunately, it uses the same a lot of the same theory behind the way we would use a range. Okay? Text 0 up to, but not including 4. So notice that basically this kind of uses a subscript notation, except we've got two numbers separated by a colon. This. It goes up to and grabs indices 0 through 4. If I were to do text 0 through 8, gives me characters, it gives me the first 8 characters, right? 8 minus 0. Goes up to, but does not include character 8. Incidentally, text 0, 8, and then the optional argument at the end, 2, like that. tis. Every other character. Okay. Now, beginning, ending, step, just like range. Just like range, we can omit things. No, sorry, unlike range, we can kind of omit things. Text. So here, this looks like what in the world, but essentially what it's saying is that if you leave this out, if you leave out the beginning, it assumes you want to start at the beginning. If you leave out the stopping point, it assumes you want to stop at the end. And if you leave out the step, it assumes you want to go all the way to, you want to go by ones. So this is a slice that basically gets everything. In fact, that's basically the easiest way to create a copy of a string there is. This translates to 0 text by ones. But honestly, easier to write this. Now if we want every other character, T subtiltig. Also, really cool shortcut over here. If you want a string in reverse, easiest way to reverse a string in Python is to do it like this. In this case, it's smart enough to say, well, actually, the user doesn't want to go from the beginning to the end. He wants to go from the end to the beginning if we're going to go down by -1s. So, it is a, so slices are pretty cool, and they're useful for extracting different things out of text. They're very, and again, we really don't need to use them too much for homework, but they're nice to use, and you'll probably see them on the practice exam and the exam just because they're useful. Yes?
You can slice things out of lists too?
Oh yeah, this is what's great about working on some strings. I don't really have to talk about lists too much because L is equal to, let's go ahead and make a apple, banana, cantaloupe. Don't know if that's how you spell it, but whatever. Durian. What's an E fruit? I don't know. That's probably good enough. Okay. L, if we slice from 2 to the end, we're just going to go from index 2 to the end, which gives me cantaloupe and durian. We're not going to work so much on string. I'm not going to worry about strings for the exam. Sorry, for lists on the exam. Just that's the cutoff point. I'm not going to, even though we're going to talk about lists right here, I'm not going to address them on the exam because I might as well just work on strings. I can't say with certainty what's going to be on the exam until Thursday because that's when you're going to get your practice exam, right? That's fair, I think. And then I'll let you know whether it's on and then on Thursday I'll let you know whether your exam is going to be here or here. It might feel like it's a bit too much right now, but I'm going to be the exam, since I plan on giving at least 3 exams, it's going to be tailored to the fact that basically that this is introductory right now. So it's going to be a large survey, but nothing too heavy on any particular thing. All right? I think we're at a perfectly good. Can you stop that? It just keeps popping at me. I think we're at a perfectly good stopping point for the content of the class. I have office hours at 4 o'clock to 5 o'clock today. I'll see about if I have time to do extra office hours this week to make it up. If you can't meet me and you aren't in right now and you tried to meet me on Monday or something, I can meet with you virtually or something. Also remember your TAs all have office hours and there's a tutoring center where your undergraduate TAs have their office hours. Okay.